Today we're going to learn how to use Logism-Evolution. So in front of me here, Logism, I just started it. When you start it, you see different options. On the top left, you see here design and simulate. So the default is design. Under design, you see different option. Is main, talking about this main area. The main area consists of this two-dimensional shape. And you can see here there are dots that represent this very similar to the breadboard structure where we're gonna build our circuit. So this is the area where the circuit will be built. In order to do that, we're gonna need a lot of component, digital component. It's wiring. You can see the wiring here in the option, the logic gate, and many others. So let's start by learning how to use the most basic gate. We're going to start with the inverter. So the inverter can be found here, and when you click on the inverter and then you place it on the board, you can choose what size you want. So you can see here the different options, the orientation. So it's pointing to the east. You can see here it says pointing to the east, and number of input, you can control that as well, but for our purpose now we need just only one. And the side, if you want it wide, you want it narrow. All right, let's make it wide for now. All right, and you can even give it a name. You can give it a label. All right, so here is the input, and this one, the right side output. So I want to have some source for the input, so I'm gonna just press down with the mouse and let go. And you can see the line is in blue. This indicates that there is no power yet. And I'm gonna just press down and drag to the east, to this direction, and it forms the output, and the output is right, but that means it is indeterminate. It could be 0, could be 1, because the input is not clear yet. Okay, so let's connect this part to some input. So one way to do this is to use some digital input. What this means, 0 or 1. So I'm gonna go here on the top here. I'm gonna add pin. All right. Connect it, and you see it's by default 0. All right. Also, I need to connect the output. I don't have to, but I can connect the output. So I'm going to find an output pin, which is this guy. I make sure it's connected. Okay. And now I have my circuit complete. So I want to test it to see how it works. So you can see here, this is the edit, the arrow, and the hand indicate that this is simulation. Now I can run the simulation. So I click on that. So I want to see, when I put 0, you see it's 1. So what happens if I put 1? You see it's 0. I can toggle between these values. So this is a way of testing my design. So I'm going to go back to edit mode. This time I'm going to go ahead and build an AND gate. Okay, so I can find it here, or I can go and find it here. Where's AND gate? I'm going to place it here. And you can see by default it has 2 inputs. You can read here the description of the circuit. So when you click on it, you see their corner become square. That indicates this is the active gate or component, whatever component you're working with. And here tell me the property. So for example, if I want to have 3 input, I will go and write 3. And you can see 3 input. But for our purpose, we want to just use 2. All right, let's build input output for the AND as we did with the inverter. So again, I find the first input and I press down and I drag and then let go. And I do the same thing for the other input and the output. All right. And you can see here the input again in blue, meaning there is no input, there is no power, nor no high, nor low. And the red indicate the output is indeterminate, is not clear. Could be either high or low, which is understandable. Let's go ahead and do the same. We're going to connect this to digital source. All right. And then I'm going to use the output again. It's just another indication. All right, to know what happened when I apply different values to the input. Okay, now I'm going to switch to the simulate mode. Now what we have 0, 0, and the output is 0. I'm going to go ahead and change this one to 1. So the input now is 1, 0, and the output is still 0. I'm going to change, I'm going to reverse 1, 0. Again, the output is still 0. When I put them both 1, the output is 1. And this is consistent with the behavior of the AND gate. This is an AND gate. Okay, let's do one more thing with another gate. This time I'm going to use the OR gate. So I can find it here or I can find it here. Right, let's going to use this one this time. Okay, here's the connector. Same height, and you can see this flexibility. I can change uh, the uh, the size. I can expand it, shrink it. So Logism give me this flexibility. Okay, so here, and I can also copy. So let's say I don't want to do the same thing again. What can I do? I just select this part. I'm gonna have Control C and then Control V, and I can drag the whole thing there. If you want to do it faster, okay, the same thing. Cut and paste just to make my life easier. Okay, now let's see how the OR behave. We gonna run the simulation. So on both 0, the output is 0, 1 is 1, is it's 1, one of them 1 is 1, the output is 1, 1 both 1 is 1. And again, this is the exact behavior of the OR. I can experiment with this. For example, let's say I want to see how the AND and OR behave at the same time. So what I'm going to do, I'm going to connect this input. So you can see this circle indicates there is connection there. I'm going to shrink the other one. So I'm going to make them share the same input. I want to see how they behave. So you can see when both input on, the OR here and the AND behave the same thing. But when I change I'm going to enter the simulation, when I change one of the input, so the OR remain 1, but the AND become 0. If I change due to the other way around, again the OR remains 1, but the AND turn to a 0. When both are 0, then both are 0. So maybe this is a good way to see how they behave if you want to compare. But you don't have to. Let's say I change my mind. I don't want to delete this. So you click on that side on the wire, and you can hit delete on your keyboard. All right, and you can delete them. If you want to go back to your original design, you can do that anytime. Okay, so what else? We can also experiment with other gate if you want. Let's say this is the XOR. How this one behave? Let's see. This one, we're gonna have the input here, and see how the XOR behave. So what happened? What happened if I let's say I use some input in a wrong way? Let's say this one I connect it. This is the input. Let's see what happened if I connect it here. Okay. Let's see what happened right on that. So you see a red line. So what that mean? Here, like creating a short circuit. This is an error. All right, and the error stems from my choice. This is an output. This is, but this one is an input. So this one is not a good option. I need to find the right one, which is this guy. So I'm gonna just delete. That's fine. But every time you see a red line, that means the absence, the value is not clear, or your wiring is not done properly. Okay, so let's see the behavior of the XOR. So let's start from when both 0. So when both 0, the output is 0. When I change 1 to the value 1, the output is 1. I'll change the other way around, it's 1. See what happens when both are 1. So it is 0. So, and this is consistent with the behavior of the XOR, which is only accept, or the output becomes 1 only if either of the two, but not both, are 1. So they have to be 1, 0, or 0, 1, but not 1, 1, or 0, 0. Okay. All right, so let's do a more interesting thing. So I'm gonna go ahead and move these away here, and then we're gonna build two complement circuits as indicated in the textbook. In the textbook, we had this image, you recall. And I'm going to place it here so we can see. So this is figure 2-3 in the textbook, representing the two complements. Two complement is a way of representing a negative. You watch the video or read the chapter. So it consists of a series of inverters or NOT gate. You see them here. So we're gonna build this circuit. So it is 8-bit. All right. And then the way that the two complements work is they take the first complement. All right. So you see it here. These are the initial values converted. They are being converted into their opposite value, and then 1 is added. So we're gonna do right that. Okay, so I'm gonna do it. For this, we're gonna need to use, you're gonna go here to this component, and we're gonna find under arithmetic, we're gonna find adder, and you see it here. This is circuit of the adder. So we're gonna study this in detail. We're gonna study the adder in detail, but let's have some idea. When you click on it again, you see the description. It says about the number of bits. So 8 bits input. So if you want to know what this means, just put the cursor and it will tell you. So you can see the first one, the top one, so the first input, and the second is the second input, and here on the each side is the sum, the result, and on top is the input, the carry in, and this is the carry out. So we're gonna see what they mean here. Let's just do some demonstration. So I'm gonna do the same thing I did before. I'm going to connect the input to the first input, and you will see that they have an orange line that said there is some compatibility problem. Why? Because the adder expect 8 and the input is 1. So you can change either one to fit to make them compatible. So I'm going to change this guy and make it 8. So I'm going to go here. I see instead of 1, I'm going to just choose 8. And you see when this one became 8, it's no issue. So the thick black line indicate there are multiple bins here. I can do the same thing here, or I can just copy this guy here. So I'm gonna cut and paste. So instead of save myself some time, I'm gonna do the same connection here. Okay, so the same goes for the output. If I go ahead and connect, you will see complaint. So I'm gonna go and fix this one, make it 8 as well. Alright, so now I got everything set, so I can go ahead and use it. Let's run the simulation. So let's say I'm gonna add 1. This is 1 in binary plus 1 0, which is 2. You can see it's in fact 3, right? Why? Because 1 plus 0 is 1 and 0 plus 1 is 1. And this is the carry out. This is the carry out. What that means, there are some operations where the value is bigger. Let's see what will happen if we have a carry. All right. So I'm gonna go ahead and add some outputs. So here I can hit. If I want it to be pointing down, I can hit the down arrow, or just leave it like that. So you can control the direction. You can see here to the west. I can make it south. All right. I can make it north, and so on. Okay. Let me make it this way. All right. So as you can see, the result is 0 because there is no carry. There is nothing carry over. But let me have some input where carry can really show. Okay. So in this case, what I need to do, I need to have a really big number here. So I'm gonna have a number where both at the end are 1. So when we add here, say 1 plus 0 is 1 as before, and 0 plus 1 is 1, and then 0 plus 0 is 0, all these 0. But here, we have 1 plus 1 is 0, and we have a carry. The carry is here. So the result will be here is 1, 0. Imagine the 1 is here, 1, 0, 0, 0, 0, 0, 1, 1. So this is the case when we have a carry. And sometimes we may have a carry in as well. That's going to go here. So let's do that. Okay, I'm gonna make it pointing downward. Oops. All right. Okay, so this time we have a carry. So what happened? Let's experiment with it. Okay, so before, if you before we change this one into some value, you can see the result is just 3. But see what happened when I change this one to 1. Okay, it's become different. It's like having now 1. Imagine the 1 is here. Added to this, 1 plus 1 is 0, and I have carry here. And there can be 1 plus 0, 1, and then 1 plus 1 is 0, and this one will become 4, right? So which makes sense, okay? Because 1 plus 1 plus 2 is just 4, right? 1 coming here, 1 here, and 2 here, 4. So I hope this make it clear what we mean by the carry in, carry out. All right. Okay, so now we know how the adder work. It just again take two inputs. You can see them here, and it give me the addition or the sum of both. And if there is a carry, it will take that. This is called the carry in. You can see C in, and if the operation leads to carry out, then this one will be indicated. But we are not to be concerned by the carry out when we try to implement the figure 2-3. You see it here, and so we're gonna go and recreate this using Logism. So one way to do that is to use the a bunch of these inverter. Okay, so I just make them pointing down. I'm gonna make them small so they don't take up much space. Okay, make copy. All right, and again I make another copy just to make the process easier. I have 4. I duplicate this to make 8. Okay. All right, so I have 8 of them. The very first step in creating two complement is first to get the one complement. So we're gonna do right that. So I'm gonna do some wiring here. So we're gonna use the long way, and then we're gonna see how to make it easier. So I'm gonna go and do the longer way, which make it look like the one you see in the book. And then here is my input. I make them pointing down by hitting the arrow down. I connect, I copy, another copy, and the final copy. Okay, so what I just built is this part, the first one. This is the one complement. To test that, we'll see. So you can see here they're all 0, it become all 1. You can see the color here. I don't have to build an output. I can use one of these component, for example, to show a light or to use another output, but you can see here. So if I change this one to 1, you can see this one become 0. If I change also the first bit to the 1, it becomes 0. You can see it's working fine. So here give me the one complement, and then to get the two complement I need to add. So this is one way, but I'm gonna use this one. Is gonna be faster. So instead of having all these input, you can see here there are 8. I already have them here in one place. So what I need to do, I need to do the inverter. I need to use the inverter to invert or to switch the every input into its opposite value. So I'm gonna be working on this guy here. So I'm gonna do, I think you're already guessing what I'm gonna do. I'm gonna shorten this line. All right, from here I'm gonna go and bring the inverter, connect, and of course gonna complain. Why? Because only this one take only one input. I'm gonna go and change it and make it into 8. So you can see here it's happy with this. So I have now exactly this part is now exactly the same as this. All right. So now what is really left is to make the design behave as in the diagram here is to make sure that the carry in is 1. I have it here, is already 1. And this one is not really important. I can even delete it. I don't really care about that. So I'm pretty much done. So the important thing is I'm gonna keep the bottom input here, but I'm gonna keep it 0. Maybe I can even put this one and connect it to the ground. Okay, this is one way, or make sure that they are 0. If maybe a better way, I'm gonna leave it for you to do it as exercise. I'm gonna go to the ground here, you see it, and connect all of these lines to the ground to make sure they are all 0. But now we understand they are 0, so I'm pretty much ready. I'm gonna go ahead and run the simulation. So if I put, for example, 2, okay, and you can see here is the output is the 2 complement of the 2. In other words, if this is 2, positive 2, this is negative 2. If this is positive 3, this is negative 3, and so on. And how we're going to check that? You can add this number plus the number, you're going to give you 0. Please, I really encourage you to do that. Let's say 5. This is 5. This is positive 5, this is negative 5. And if you add these two numbers, this and this, you're going to get 0. Of course, you're going to have carry in the end, just ignore it. So I hope this video helped you understand how to build a circuit, how to build the inverter, the AND, the OR, the XOR, and many others, and also explain to you how to build a circuit that does the 2 complement. Take a number and in its positive form and give you its negative value.